I know these problems can be hard for students. So let me kind of show you again a strategy of how to solve angular and linear velocity problems. There really isn't a whole lot of things that you can work with when you solve these problems. There is a minimal amount of relationships that we have. The first one we have is that omega, which is angular velocity, is equal to the amount of radians per unit of time. Okay, so radians per time. The other relationship we have is that linear velocity is equal to angular velocity times the radius. That's all we have to work with. Whenever you're doing a problem that requires you to think about angular speed and linear velocity, make sure that you write these two things down. Start there. Now, you got to think about what you have and what you want. Okay, the problem gives us that you have a wheel whose diameter is 32. Now I look up here, 32 inches. I look up here and I don't see diameter, but I see radius. So I want to change it to radius, 16 inches. Now they also give us that it's traveling 60 miles per hour. 60 miles per hour. And I think to myself, okay, of all these three things right here related together, which one is 60 miles per hour? Well, when you're traveling in your car, and you're going 60 miles per hour, that's your linear velocity, okay? That's what your speedometer tells you. It tells you linear velocity. So I can actually name this linear velocity. So now, in this equation, I have two pieces, and I have an unknown. This is the thing I don't know of those three things. The question does ask me, though, how to find that I need to find angular speed, and that's what omega is, okay? So like we normally do in mathematics, we take an equation, a relationship that we know, and we fill in the numbers. So I have 60 miles per hour is equal to omega, the unknown, times my radius, which is 16 inches. Now, the only problem is this is in inches and this is in miles. So just go ahead and solving this for omega, it would be wrong. So you want to convert one of these to either convert this to inches or convert this to miles. You got to do one or the other. So I actually like taking miles and putting it in terms of inches because I'd rather use bigger numbers than smaller numbers. So I stop here. I go off to the side and I want to convert 60 miles per hour to inches per hour. So if I do this, I know that in 1 mile there's 5,280 feet. And I know that in 1 foot, there are 12 inches. Now down here, if I just continue this down, this is going to be 60 times 5,280 times 12. And that cancels the miles, the feet cancel, and then that leaves me with inches per hour. Now let me get my calculator out and see what that number turns out to be. Where is my calculator? I don't see it. Are you on my calculator? Well, oh, there it is. Sorry, guys. Here's my calculator. All right. So let's see. I want to do 60 times 5,280 times 12. And that gives me, let's see if I move this to write it down, 380.1600 inches per hour. Now, I can go back to this equation and I can say 380.1600 inches per hour is equal to omega times 16 inches. Now I can go ahead and solve for omega, which is what the question is asking. So omega is equal to 3801,600 divided by 16, and that's going to be radians per hour. So let's see. If I stick this in here and divide by 16, 237,600. So omega is 237,600 radians per hour. Okay. Now the question isn't over. We found the angular speed. Now how many revolutions per minute do the wheels make? So that's just another bit of conversion. So we always get revolutions from angular velocity. So always angular velocity will always yield RPMs or whatever, revolution per unit of time. This one, they say we want revolutions per minute. So we got to convert omega to revolutions per minute. So again, I'm going to rewrite this. My RPM is going to be 237,600 radians per hour, and just convert. I have to convert hours to minutes, so 1 hour is 60 minutes. So that takes care of that conversion. And I know in 1 revolution, I have 2 pi radians. So the radians cancel, the hours cancel, and I'm left with RPM, revolutions per minute. So the number of RPMs is equal to 237,600 divided by 60 times 2 pi revolutions per minute. Let's see what this number turns out to be. So 237,600 divided by 60 times 2 pi. Make sure that 60 and the 2 pi are multiplied together and parentheses around them. So that's 630.2536. 630.2536 revolutions per minute. Now that makes sense because the car is going pretty fast. It's going 60 miles per hour, a truck in this case, 60 miles per hour. So remember, when you start these problems, whenever you have angular velocity and linear velocity, start with these 2 statements right here. Write down all the stuff you have and see how they fit in here. Sometimes you'll be given R and omega, sometimes you'll be given linear velocity and angular velocity, but you'll always be given 2 of these bits, or maybe some information to be able to find omega and then the radius. But this is it. You can't go past this. You have to start here every single problem. And then you either create these numbers based on what they give you up here, or you are just literally given them like you were in this problem. And you also pay attention to all of the unit change, because that's really important in this problem. All right, I hope that helps.